Thanks, Ryan. So my name is Luann Freund. I'm from the University of British Columbia at the School of Library, Archival and Information Studies, now known as the iSchool at UBC. We've rebranded. Why not? Get on that bus. And what I'm going to be talking about today are three interrelated factors that play a role in the HCIR dynamic. These are document usefulness, document genre, and information tasks. This work is motivated in general by my interest in non-topical, pragmatic approaches to human information interaction in digital domains. So I'm interested in what motivates people to search and how that affects their behavior, and also, in this case, I'm going to be talking about their assessments of documents in terms of usefulness. So the questions here, broadly, what does it mean to say that a document is useful for a given user? More specifically, what is the effect of the motivating task and the document genre on usefulness? When I speak about document genre, I'm talking about categories of documents that are recognizable to searchers, to people, based on differing communicative intents. So documents that are designed to do different things usually look differently, and people can recognize those differences. So things like reports, memos, FAQs, guides, fact sheets, etc. I'm also interested in this study. I'll talk a little bit about the extent to which these genres are recognizable and distinguishable by searchers. One of the challenges in the genre domain is, as Gary was talking about, it's one of the scruffier kind of things you can look at in information environments, because different groups think about genre in different ways. It's very often domain dependent, whether or not you would recognize a particular genre. So it tends to be a little bit difficult to capture. So we're looking at that a little bit today as well. I'm focusing on the e-government domain. And the reason that I think that search in the e-government context is important is that, first of all, we all need to access government information just to sort of run our lives. So it's pretty much everybody needs to find this information, and pretty much all of us are non-experts when we search this kind of content. So I think there's a lot of room there for system designers to develop systems to support this kind of activity, and assume that everyone from your grandmother to your 15-year-old are searching this kind of information and need to find what they need to find. The study I'm going to talk about today is an experimental user study, and the study was a document assessment study, so it didn't have people actually searching. I was focusing on this issue of usefulness assessments of documents. 25 participants, university students, Canadian residents. This was important because, as I said, genre recognition is domain specific, so I wouldn't expect people from another country to be able to navigate through a Canadian government information space. Each participant carried out 5 tasks and in total assessed 40 documents, so 8 documents for each task scenario. And they did a usefulness assessment. This was a 7-point Likert scale from not at all useful to very useful for each document. They also talked a little bit about how they made that assessment, and they did some genre labeling as well. An important direction in my research is the idea of different task types. So here I'm not talking so much about search tasks, but rather what I'm calling information tasks. It's a bit of a higher level task category. So what motivates you to search? What brings you to the table? And the 5 types that I'm talking about are fact finding, which is actually the closest to what we think of as a search task, but also deciding, doing, learning, and problem solving. So in this study, we created 20 situated work task scenarios. You have one example here for a doing type task. You can see that searchers were given quite a bit of context to draw upon in an effort to prompt fairly naturalistic assessment behavior within the limitations, as always, of a laboratory study. And so for each type, I had 4 different examples of tasks. So I had 4 fact-finding, 4 doing, 4 deciding. And that's important because I think that to really start saying that we're talking about task type differences, we have to have multiple examples of each type to say that a single scenario represents a whole task type is problematic. So I was trying to get closer to that in my work. The documents are documents that were drawn from the Canadian Federal Web Domain, the gc.ca domain. And we retrieved these documents by running simple Google searches. We derived a simple query from each scenario, searched on Google, limiting it to the government domain, and retrieved 20 documents per scenario. From those 20 documents, we selected 8 documents that were somewhat varied in genre and used those for the assessment task. I would have done more, but I couldn't keep the people in the seats long enough to do that, to spend that much time assessing documents. One of the challenges here, again, if we go back to this issue of the challenges of doing user studies, is that you can't really control genre examples because they're kind of organic things. They live on the web, people create them, people use them. So if I would have carefully, taken content and morphed it into 5 different genres and fed it to people, it wouldn't be realistic. It wouldn't carry the weight that real genre do. So a limitation here is that I have no way of knowing that there was equally useful documents for each scenario, but rather that they're a diverse set. And you can see some examples here of the kind of things we're talking about. One example is clearly a guide. One is clearly a press release. These things are common in the Canadian government web domain. And the Canadian government even has a metadata taxonomy for document types or document genre, and there are 50 different genre type on that list. They don't use it very consistently, but it exists. Okay, so there's some potential there to work with it. And one of the interesting characteristics of this study is that we had at least 5 assessments for each document, for each scenario. So one of the first things I want to talk about is the degree to which usefulness assessments are consistent. And that is not in the paper here, but it was in another paper, and I think it's interesting, and I want to highlight it. So we did this analysis of interclass correlation coefficients to look at the consistency between judges. And basically, there is no consistency. So people simply do not agree about the extent to which a document is useful. And you might think that giving them these more detailed scenarios would prompt more consistency. I suspect it's the opposite. The more context you draw upon in making an assessment, the less likely your assessment is going to be like your neighbor's. So overall, 2.84, correlation very, very low. And then we actually have the opportunity here to look at the differences across tasks, and I think this is even more interesting that we see that fact-finding is the only task that has some reasonable kind of mid-level correlation. And for problem solving and learning, there's almost no consistency there. So really brings into question, I think, some of what we do, frankly. Okay. Other effects that we saw, the effect of task. So there is an effect of task on usefulness scores. They vary significantly by task. In general, fact-finding and learning, people find the documents to be more useful, or they're less critical, if you like. They assign them higher scores. For problem solving, they're most critical of the document's usefulness. There is also an effect of genre. So there are certain genres that people generally find more useful, or at least in this experiment. Home pages, very high, which reinforces a lot of the high ranking that home pages get in web search. Things like news and reference materials, perhaps because of the particular scenarios here, people are probably less interested in the government self-promotion efforts. So they give those less. And here's where I think we have a useful result here. In particular is the interaction effect between task and genre. So we see that genre makes a difference for 3 of our 5 task types. Genre matters when you're doing a doing task, when you're doing a deciding task, or a learning task. We have significant variations in the usefulness scores among the genre palette that we're working with. But in fact-finding and problem-solving tasks, there was no significant difference. So here you have the most complex kind of task, the most difficult. I'm not sure exactly whether it's the complexity, the difficulty, but problem solving is known to be a complex task, and genre doesn't really help us there. So in other words, if the task is really difficult, any document that helps you is good. Fact-finding, very simple, usually, discrete tasks, and in that situation, any document that contains the fact you're looking for is good. Doesn't matter what the format of it is. If we turn to the genre identification part of the experiment, people found labeling genre that they encountered to be very difficult. As one participant said, I didn't really know how to describe them other than information. They were reports of website pages with info. So they've got these really general vocabulary terms. But we saw, on the other hand, that it does make a difference in how they search, but they don't know how to tell us that. So it is an implicit form of knowledge rather than an explicit form of knowledge. In terms of labeling, they used multiple labels, and so with on average about 3 labels per document, they correctly labeled about 50% of them, but only about 25% of their labels corresponded to our expert assessment. So there are challenges there. If we take the group labeling and we say across all 5 people what was the most common label assigned, it did match for most of the genre. It matched our expert assessment. So there may be some benefit there in doing group labeling and using that as a way to assign labels. Implications: people don't agree about usefulness. Surprise. As searches become more difficult or complex, usefulness scores drop and agreement deteriorates. Genre does matter, but not for very simple or for very complex tasks. So we need to think about ways to create task-based searching approaches that take into account genre. And genre knowledge is implicit and situational. So our common way of making use of genre is to give people a browsing structure with genre categories. Well, I don't think that's going to be very useful because I don't think people think that way. They're not aware of the terminology. They're not specific or consistent in their use of it. But a system that says, hey, you're trying to build a garden shed. Let's give you documents that are about building garden sheds, that have instructions. That may be a more effective approach. And some acknowledgements, and that's it. Thank you.
They may not be able to keep these labels, but they might be able to, for example, search them into category directions. This is my blobby pile. This is the spiky pile. Hard sort or
other studies have been done that have found within particular domains. Mark Rosso's work has found hard consistency in hard sorting type things. But most of my participants, they defaulted to putting multiple labels on things.
but wasn't that the only mechanism?
Yes. Well, I'm not sure what is the difference between putting multiple labels or putting a document, telling them it has to go in one pile? Yeah, that perhaps if they had to only choose one. Right. So the experts were us, the research team, and we basically worked iteratively on decisions. Not very high. Not very high, especially when you have to choose a single document, a single genre label. I really think that multiple genre categorization is the way to go, but in order to have kind of a study that made sense, we opted for that. You have some query logs for me?
Oh, I don't but I have an idea of this. On that thing, on the posting houses, how can it be more?
Yeah, so I'm curious if you would have any better luck if you made in some way these nominal choices less binary. So, for example, if you ask people, well, how violently do you disagree with it being of some genre in this kind of iterative flow, or somehow put these in a distance states that were more flexible? Do you have any intuition on that?
First of all, they found it difficult. They just told me they do not think like this. So that was the first obstacle. When I asked them, how difficult is it to make these genre assessments versus how difficult is it to make usefulness assessments, it was easier for them to assess usefulness than genre. But yeah, I think there are ways in which we could make it an easier task for them if our goal was to kind of find labels and attach them to documents. But in real time, I'm not sure.
Okay, so our next speaker is going to be Jean. There we go.
Hello. What I'm going to be talking to you today about is some work that was done at FXPAL over the last couple of years, well, led up over time, with Jeremy Pickens and my intern from the summer, Abdi, who is from University College in London. And what I'm going to be talking about is collaboration and information seeking. And this is a practice that we've heard about today, and many of us have engaged in whatever, whether it's in your personal life, doing travel planning, or looking for medical advice with your family, or in the legal domain and medical domain. There's all sorts of places where people work together to find information. And in most cases, this activity is very poorly supported by existing tools. There are a few exceptions, but mostly people send email or do IM or exchange URLs in some way, or even hand out printed pieces of paper. And the basic problem, there's several basic problems, which we can group into two main classes. There's lack of support for awareness of what your collaborators are doing, short of receiving their chat messages or their emails. And the system doesn't really understand that there's collaboration going on. And so we can think about a collaborative search system as consisting of several pieces, if you will. There are some interfaces through which you interact with the system to actually cause it to retrieve information. There's a set of tools that help you communicate with your collaborators and to maintain awareness of what they're doing. And then there's some underlying set of algorithms that are in fact aware of that you're collaborating and can do something with the various input streams that people are providing to help the team be more effective than the individuals working separately. And this is the kind of thing that Roberto and Chirag's poster was trying to assess. And the poster's just around the corner here, looking at what happens when teams work together. So we can think about this whole human-machine system as two, but really could be more than two, people working together and through a system that consists of two main components, one that mediates their communication and one that mediates their search activity, the actual business of retrieving information. And so here's a quick list of some systems that are out there. Some of them are research, some of them are actually things you can use. Roughly and very, very quickly rated by me in these four categories. One is, do they support exploration? Yeah, some do, some don't. How good are they at supporting various communication activities? Most of them are designed for that, pretty good. Awareness, yeah, there's usually some sense of some query history or some chat, so you can kind of get along. And algorithmic mediation, that is, how well does the underlying search engine represent the different streams of activity and help people actually find information? Most cases, not at all. The one outlier there is that system in the middle called Searchiamo. It's a system that Jeremy and I and Chirag built at FXPAL about 4 years ago, which was focused on algorithmic mediation and neglected everything else, almost, just to prove the point. So this chart illustrates some opportunities. In short, all of these systems do the easy thing, which is to add some chat and add some query results sharing. but very few of them actually support information seeking directly. They don't have faceted browsing. They don't have any kind of significant history, or if they do, it's kind of primitive. And certainly most of them don't do anything in terms of mediation of the search. So what can we do? And so first I'm going to talk about some really high-level sort of theoretical considerations of what you could do. Then I'll show you an interface that takes a step in that direction. So one thing you could do is when you talk about this process of mediating communication, and when you have two people communicating over some document or over some search result with chat or with comments or with some other means of communication, the system can observe that and make inferences about it. And so you could have a side effect from this channel, from this communication channel, into the algorithmic mediation component. So that because you had a conversation around some document, the system might make an inference that that document is somehow special, different, useful, pertinent, not useful, whatever is appropriate, whatever inference you can actually reasonably make. And use that in subsequent information retrieval steps. So it could use it for relevance feedback. It could use it for other things. So the example here is, you have a long conversation about some document. The system might find other documents like it, or use it in a conjunction with some other query that you ran to bias results over things that are similar to that document. You could go the other way as well. So you have this algorithmic mediation step where you're interacting with a system to retrieve information, and you might make relevance judgments, you might run multiple queries, you might do some reading, and the system can observe this either through your clicks or perhaps through an eye tracker or whatever, and can potentially make an inference from this that says, oh, this person was really interested in this document or this topic. He retrieved a bunch of documents, ran a bunch of queries. Maybe we should notify the collaborators that something interesting happened there. Examples, that you can flag documents for collaborators to look at based on documents that somebody else had used as relevance feedback. Or in fact, you can do the whole query. So if I ran a query and started saying, oh, this is great, I found this document, I read this document for a long time, maybe my collaborators want to know that this query and this result set are somehow special compared to some of the other things that I have done. Now, I could tell them, but maybe it's easier if the system does it for me in some cases. So the idea is that given these two communication channels between people and the data, can we couple the two in ways that are useful? So what we did in this Aquarium project is we built a system. We looked at what was done before. I showed you the slide, and we identified some opportunities. We built a system that actually tries to capture both the communication kinds of mediation and the algorithmic mediation, similar to what we did in Searchiamo. And then we did some iterative design, and now we're using that platform to explore these kinds of issues. So this is a screenshot of the system, and I'll be demonstrating the system later on in the day in the search challenge, so you'll get a more hands-on sense of, or eyes-on sense of how it works. But what you should look at here is you have this is a faceted set of faceted filters, and I have two kinds of filters here, and I used the year of publication for the articles that are indexed here as one facet. You could obviously add others that are based on the metadata of the documents, right? So what was the term that you used, Gary? The surrogate. So this is something of a surrogate for the documents. The upper part of the filter, where it starts with normal and then has all docs, useful docs, seen docs, that's a surrogate for the session, for the browsing session. So it shows you in this particular query result how many documents you've actually looked at, how many you've said, yes, these are useful, how many you've said, no, they're not, how many you haven't actually paid any attention to yet. And you can filter on those just as you can, and in combination with the document metadata, so that you and your colleagues can do some kind of triage on the result sets, and this may facilitate kind of a divide and conquer strategy, or a what did we do, what have we seen, what's there left to do kind of operation. So that's the hypothesis behind this interface. Okay. Below that, there's a set of query expansion techniques that use relevance feedback to take some set of documents, and different queries there use different sets of different kinds of queries use different sets of documents. I'll talk about that in the afternoon. To do relevance feedback, so you select some documents either by giving it a thumbs up or just by doing ad hoc selection, and it takes those documents and does relevance feedback, finds new things for you to look at. And then that's query result like anything else. All right. There's a query history that shows the query, might show whether relevance feedback was used or not. So you can see here, this says with 3 documents, this says with 7 documents, and this one says by Jeremy Pickens. So this is actually a collaborative tool, right? So there were 2 people doing searches here, and it shows that that particular search was done by my partner at that point. So, and I can click on any one of those things and go back to the results out of that. This histogram is an interesting idea, which we haven't evaluated properly yet, but hopefully it will make sense. This is a surrogate for the retrieval history of that document within this search task. Each bar corresponds to a query that you ran over time, and the higher the colored bar is, the higher rank that document was with respect to each successive query. So looking at that first document, you can see it's been retrieved by almost every query we ran except that one in the middle. And the color represents who ran the query. So that document was first retrieved by a query I ran, secondly by Jeremy, and then a bunch of queries that I ran after that. If you look at the document with rank number 6 here, you can tell at a glance this is the first time that's come up. Nobody's seen that before. So that's kind of again, a metadata about what's been going on. And I can look at this vertically, and I can say, okay, been there, been there, been there. This one is new. I can just focus right on that. Or if I'm trying to review, I say, well, that's not relevant, and move on, just depending on what task I have. And you can click on any of the bars and navigate to the corresponding query. This is where you make the up and down assessments. I'm going to speed up because my time is ending. And this is the text of the document. If I have a PDF, I show the PDF. If the PDF fails to load because the URL is gone, I just show the text that's been indexed so that the person can see something. The data was noisy. You have to make do. OK. Next. OK, great. So we've combined, and there's a chat facility, and you can make comments on documents. I'll show some of that maybe later. We've done some algorithmic mediation here where you can do relevance feedback on other people's queries. You can also take results of all the queries you ran in a session and fuse them together and produce one ranked list from all of the documents that were retrieved to get us, again, a sense of what's happened overall in the session. And right now, the relevance feedback stuff is manual, but one of the things we're looking at is some of the theoretical stuff for deciding when inferences are legitimate. And there's a whole bunch of questions as to whether those inferences are actually legitimate or in what circumstances you can do this. So, just because people talk about a document does not, in fact, mean that document is useful, necessarily. Sometimes it is, sometimes it isn't. One of the things we're going to be looking at is how can we tell when it's what? Perhaps you can do some sentiment analysis on the text. Perhaps the volume of traffic is going to predict something. We don't know yet. The notion of sharing versus usefulness is an interesting one. We actually did some interviews. This data is in the paper. And people had a clear distinction between when they share a document and when they mark it as useful. Now, it doesn't mean necessarily that we should treat those completely differently with respect to relevance feedback. And that's an interesting question. You can still, just because people don't think that sharing something necessarily means the document is relevant, because it could be fun or whatever, it might still be effective as a form of relevance feedback. And similarly, just because person has marked saved something as useful, you may still want to share it even though it's not an overt act of sharing. Whether that kind of information is useful or not is an experimental thing that we need to validate. So, sometimes users' expectations with respect to these things or their intentions don't actually match up with what the system can do given this information. And whether that's possible or not is the subject of next year's presentation. Thank you. Well, the two-word answer is, of course, it depends. We've heard that one before. I think that some of the factors it depends on are the collection and the kinds of search tasks and the kinds of metadata that are available, because in some cases you can make pretty good relevance feedback works effectively in some cases if the vocabulary is focused and you can pull things together. If relevance feedback isn't working very well, then obviously you don't want to be making these inferences. But beyond that, I don't know. We have to actually play around, get people to use the data, and see what we can find by doing these kind of speculative analyses.
Really cool ideas. I also like how you said how do you really interactions with
well, I think that my feeling is that some inference is appropriate and will lead to better performance. So what we need to do is just collect enough data and test it to see. And so how do you test this? Well, let's say that people use the system and for a particular topic, and it doesn't matter whether at this point whether it's one person or more, they ran 10 queries. And they made saved some documents or used some documents in some way that were retrieved by those 10 queries. You can look at the entire set of documents in aggregate and say, okay, we found these, in the end, these things were the ones that people found useful. Now, it turns out that 5 of those 10 were retrieved by the same query, but at such low, by the first query, but at such low ranks that they never saw them. And then some more came up in some subsequent queries. So now you can, using that as the ground truth within that session, you can do speculative analysis to see how well what kinds of algorithms can you apply that predict the retrieval of those documents at high ranks. And then now you have to figure out how best to communicate that, whether it's through some recommendation thing, or whether there's some intelligent agent whom you're collaborating with, or some other means. There's some user interface treatment of this that makes the recommendations palatable without necessarily disrupting the organic results, which people might still expect and be able to understand easier. But that's, again, whether such an, I think that that's the kind of analysis I want to do, but I need some data first, and I'm going to be collecting this data in the next few months. Yeah. Yeah, that's right. Yeah, that's what the query fusion does. That is, we do a rank fusion on the results of all of the queries that have been run in a session, and documents that consistently come up, even if they're ranked low, get a combined score that's higher than documents that are retrieved only sporadically. And furthermore, we weight the ranks of each query by how many useful documents, the saved documents, that query retrieved. So this is the cluster hypothesis in operation, that if you ran a query and found a lot of documents to be useful that were retrieved by that query, we expect that it's likely that other documents also retrieved by the same query would be more useful than documents that were retrieved by a query in which you didn't save anything. It's probabilistic, and it's just a little bit of a weighting, but this is something that we did in the search YAML system as well. It seemed to work okay. Yeah. Right. So this should scale just fine to small groups where you do in fact know everybody. 4, 5, 6 people should be fine. Beyond that, I think the notion of relevance breaks down because you have no guarantee that everybody's on the same page with respect to what they're actually looking for, even if they're running similar or identical queries. So you kind of need to back off a little bit. And in fact, there was a poster, I'm blanking on the name of the person who presented it. Yeah, Scott, who talked about collective information seeking, which I think is more what you're talking about, where you can make some inferences. It's not just a recommendation system, but you can actually make some inferences about the fact that somebody else is looking for the same information kind of at the same time, and you kind of maybe know that person through some social graph. Now, in the case of Ancestry, it might be that you have some shared trees or something like that. Or maybe you're interested in some of the same surname. You could establish these kinds of correlations in some way. And once you have that information, you might be able to use that as a catalyst for more explicit collaboration. But you need to treat the task sensitively because judgments of usefulness or relevance are tricky. Because just because you found something doesn't mean that I would find it relevant to the same query, if we're not sharing explicitly. Yeah. Thank you.
Okay. Hi, and no, I'm fine, thank you. Oh, okay, so you put your own timer. Great. And did you copy your slides?
Yes.
You did.
Mm-hmm.
Okay.
5 or something.
Yeah, I was forgetting.
Hi, my name is Aliona Medelian, and I lead the research at a New Zealand company called Pingar. And today I'm presenting joint work that we did with Anna Divoli. She was a postdoc at the University of Chicago. I actually found a screenshot of one of Anna's work in Marty's book and contacted her because it looks so similar to something that we developed at Pingar, and I wanted to evaluate it. But I've never run a user study before. So I suggested we collaborate, and luckily Anna said yes, and these are the results of our research. We decided to study the features of a search user interface and how useful they are. And we focused on bioscience because this is one of the verticals of interest to Pingar and Anna's background as well. We have identified 5 features that were of interest, and here they are in a very typical system that is used for searching biomedical data, PubMed. One is autocomplete, and you guys are all familiar with this. Search expansions are ways of modifying the search query to find more results. We also looked at facets, and PubMed suggests the facet of refining search results based on their type, but there may be many other ways of using facets as well. Related searches help to refocus the search, and results preview shows, in this case, what is the title of the document, who are the authors, what's the journal, and yeah, it depends. We added a second dimension to our research by looking at the search tasks similar to Leanne. In a paper by Keller, they found that majority of the tasks are related to transactions, such as writing emails, doing online banking. And the remaining tasks are spread evenly between fact-finding, information gathering, and browsing. We actually found that in bioscience, it's pretty hard to identify the task, the type of the search tasks. But looking at these actual descriptions of search results by our participants, you can see that there is some similarity. So animal models of Huntington disease is quite specific, so we call it a fact-finding search task. If a researcher wants to find information on that relates to their own studies, it's information gathering. And if they're just browsing a new publication in a given area, then it's browsing. So our research questions were, how useful are the 5 features of a search user interface for searching in biomedical text, and how that, and we hypothesized that it depends on the search task. And in addition, we also wanted to find out what works best in terms of representing and computing facets. Our hypothesis was that it's better to display dynamically computed facets rather than a complete list of everything that's available in a facet hierarchy. We first ran an exploratory study where we emailed, we interviewed and questioned several bioscientists and just asked them in general, explained them the search tasks, and asked for typical queries that they would categorize under those types. We then used the results from the study to design our main study with 10 bioscientists. They were all experienced researchers, and they were very keen to participate because they did their current.
Oh, you're not muted.
What's happening?
I'm working on it.
We emailed the participants in advance and asked them to provide us search queries.
Anybody have one of those iPhones?
And so we used the responses by the participants, the actual search queries that they use in their work, to create screenshots of how various systems implement specific interface features. So here we used the PowerPoint presentation to compile them all in one place and show it to participants. And here's this presentation for one of our baseline queries, Connexin. Can anybody recognize where is Google and where is Bing here and where's PubMed? I can. So we didn't tell the participants which system is which, but you can see that how different systems treat such a common feature as autocomplete. We also had a commercial system, Go PubMed, and NextBio, another commercial system, and a research prototype, Semedico. So not all systems implemented all of the features. For search expansions, we had an internal implementation using finger technology, which is presenting a checkbox, and if the user selects it, we build a Boolean query. And PubMed, you already seen this example, has quite a specialized search expansion option. For faceted refinement, we tested several systems developed by Pinger using our API. And we also used Solar to generate facets based on existing metadata assigned to medical articles. At the bottom, you see the PubMed facets, and E is a system with a full hierarchy of terms from a research prototype. We also tested the same presentation, but with checkboxes, and Go PubMed used checkboxes for their facets as well. We also looked at related search queries, and you can see how different the suggestions are that users would get if they use those systems. So we were focused specifically on the content, but also collected users' ratings on design. In terms of the search results, we have compared only 2 systems, both developed at Pinger, and one is using standard tools available through the Solar search engine, which is C. We compared keywords that were driven from the metadata assigned to the articles with those that we automatically identified using our keyword extraction tool. And for previewing the actual content of the document, we compared snippets calculated by Solar with a text summarization tool by Pinger, where you mouse over and the context of that sentence is displayed. We have collected a lot of data and put it all into a single spreadsheet, and I would really welcome those tools that make user studies less of a hard work. So in the first column, we compiled all the information we knew about each participant, and all the remaining lines represent ratings of various features. So you don't have to read this, but this is a rating of one participant and how they evaluate the autocomplete for the query animal models of Huntington disease. We asked them on the Likert scale how useful they would consider this feature when searching. And below, we have collected scores for individual systems separately for looks and for the content. And we also ask them to rank the system in order of their preference. We then ended up compiling the results to support our research questions. And the first research question was, how useful are different interface features? So, and whether it depends on a search task. So here we have a stroke representing a single participant, and green denotes the positive ranking of a feature. And if we look at autocomplete, at the very top you can see that 3 people were performing a browsing task, and they all said that autocomplete is useful as a search feature. People who were performing fact-finding disagreed, and people who were information gathering were predominantly neutral with respect to autocomplete. Regarding query expansion, somewhat more positive responses on browsing, but very mixed opinions for the other search tasks. Whereas faceted refinement has been rated highly for all the features equally. Related searches, on the other hand, was negatively ranked, and this is participant commented on this. They rarely use the related searches option because they know what they're looking for, and they don't want to change the focus of their search. They're more interested in refining, and this is where facets are very useful. And the preview of search results is useful. It's kind of intuitive. You have to know what results are returned. So participants commented why they found autocomplete is less important. They say they feel pigeonholed by those suggestions, so they don't want to see them. And with regards to facets, they commented that they should be focused on their search queries. So if they're looking for a particular disease, they would like to see the symptoms, and they really like the category organisms. So, but when they saw one of the systems that had a very large number of facets, they felt overwhelmed, and we had to force them to actually look at the system because of how many colors were used there. So checkboxes is something where they all said are very useful. They want to select multiple choices. And in terms of how these findings relate to previous research, our findings are in agreement with autocomplete, but with regard to facets, other research have found that participants do like a full hierarchy, not bioscientists. So in general, our participants told us that the looks of our system has to be good enough for them to use it, but what really matters is the relevance of the suggestions. Yeah, so I think this is an important finding. So to conclude this talk, We asked whether search interface features are useful for various search tasks in biomedical literature, and we found that facets and results preview are useful, whereas other features are more useful for browsing. So if you're designing a search interface, do not waste your time coming up with a great algorithm for related queries. In terms of faceted navigation, very few query-oriented and specific values is something that bioscientists prefer, and they like to use checkboxes. Another finding is that Anna actually now not at University of Chicago anymore. She's in Greece and applying for a visa to come to New Zealand. So I'm looking forward to more experiments with her.
I have a question about why you think people find some of the suggestions, queries, or the expansions useful. Why that was? Why the particular suggestions were made? Those that were made not useful.
For search expansion specifically? So there were two comments that they made. In terms of PubMed implementation, it was only understandable for experts, people who have experience in searching in library databases. And in terms of the suggestions that we generated using Pinger technology, we actually have included various modification of the search, which also included not only synonyms, but also alternative spellings. And they said that these should be included, the spellings should be included automatically, so should be the synonyms. So they felt like the system should do it for them rather than them doing the selection.
I also had a question about the, I like how you graph it. Autocomplete response is what we see. Also the related deadline document popular very long. So that often algorithm that your algorithm.
So we, I'll show you the related searches again. And here, this is the only suggestions that were generated here. This is what PubMed suggests. And there are suggestions by Bing and Google and all the different systems. And the suggestions were generated for each participant's individual query, the actual queries that they enter. So I believe that it represents the correctly what the system are capable of. They did comment on, I think they did comment on related documents. We did not include this feature there in our study.
Just actually, the follow-up is that I'd be curious, when you have related searches, if there's a distinction between when people see related searches and say, oh, yes, that's what I want to find, versus when they actually go and click through them, and there's a disconnect between what they expected they would get, what they actually do find. So those different problems with research. And if you're able to factor that out, or if you kind of the reaction to why they want to.
The only comment that I do remember is that they just wanted to get more specific with every single action. And when they looked at some of the at the related searches suggestions, they click on the link, they felt it's gonna open another window, and then they have to deal with this. So they weren't keen on clicking on any links.
They don't want to move laterally. They want it
They,
progress.
yeah.
Thanks a lot. Okay, so we're now going to have the 4 short talks. Please hold off on questions until end. Then I'll ask all of the up here, and you can ask them at that time. Do you want us left, or do you want to?
Yeah, that's fine. Okay, so I'm going to talk to you about some really early stage work. I'm Rob Capper, by the way. I'm going to talk to you about some early stage work that I've been doing with some of my students. This project in particular with Jason Rates, one of our master's students, on faceted search on mobile devices. So we got motivated by this, Marty, because of some of your quote here, that mobile computing is growing in popularity, but there's still sort of this open question about how well faceted navigation works on small screen devices. And it turns out that this seems to be almost as true in 2011 as maybe it was in 2008. There are a lot of different things out in the wild in terms of how people are handling this. So you can compare what people are doing in their mobile devices to what they're doing on their desktop interfaces. So Target, for example, here uses sort of a single facet or single hierarchy navigation on their mobile device, but in their website, desktop site, they have full facets. JCPenney, for example, they try to mirror on both. They seem to support full facets in the mobile device and on the website. And obviously, this depends a lot on what task you're trying to support and what user goals there are. But there don't seem to be some good, there doesn't seem to be good research behind this, and even the UX community has identified that there don't seem to be good design patterns for this even. And I love this quote: designers of mobile applications don't have established user interface paradigms, and they don't have abundant screen real estate either. So we got interested in this, and like I said, this is some very early stage work, so I underscore the word explore because that's kind of what we're doing right now. And I hope that later today I'll get more feedback from you guys and you can help shape the directions we go with this. What we've done so far was to develop a system to help us prototype different types of faceted interaction on mobile platforms. And so I'm going to show you part of that today. I'll talk a little bit about the architecture, and then I'm going to show you 3 particular interaction styles that we have mocked up. So the basic elements that we were trying to support are very simple. A search box, which is the S box there, where someone's going to type a query in if they want to. My student liked to call this the cherry picking display. I think of it as the breadcrumb display. So that's what the C box is. And then the F box is where you're displaying the list of the facets themselves in some way. And then the R box is where the query's results actually show up. So the architecture that he built was using a Solr backend, the Solr PHP client interface, so that we've got a bunch of PHP libraries that help support each of those components. So the C box, the R box, and the F box. So we implemented a number of styles of interface with this, and we used the open video collection that Gary talked about earlier. So let me run through these really quickly. One is called the accordion style, and in this you've got a button to narrow the results. You press that button and accordion expands out. If you want to look at genre, that accordion expands out, and then if you choose ephemeral, it adds that to your list of active filters. But that takes up a lot of space on the screen. The next one is kind of an interesting one. It's called the teaser. It's a teaser because you get a little teaser over to the right side that the facets are over there, but you can't quite see them. And if you swipe over, then you look at this, and you know that the results are still back over there on the left side, and you can swipe back, and then you can do the same things here. You can kind of go through, and it gets added to your filters. The last one is called an overlay. This is sort of a modal overlay, where when you hit the Refine Results button, it pops up an overlay. You can expand that out, and then it gets added to your filter. So we've got a bunch of ideas where we're going with this in terms of evaluation. I think there's some interesting questions from sort of the HCI and ease of use side about how these work, but I think there's some really interesting cognitive questions about what you're able to see on the screen and how easily you're able to go back and forth from the results to the facets. So you can try the system out. That's the shortened URL, and I'd love to hear feedback from you about it.
There.
Great. Hi, my name is Keith Bagley. I'm from IBM and also from UMass Lowell. So I'm going to describe to you in very brief terms some of my early PhD research on conceptual mile markers. So, question that's been asked and sometimes answered is, how did I get where I'm at and how do I get back? And this question is not just from a information retrieval perspective, but in everyday life. So when my wife calls me up on the phone and says, I'm lost in Boston, give me some landmarks on how to get back to 93, that same question has to be realized for someone to have some useful value out of it. So landmarks, mile markers are things that in the real world we use for navigation purposes, for waypoints, and to help us get to where we want to be in terms of destination. Lessons from the travel industry that I'm trying to apply here are things like this. You know, we have general places that we want to go, and maybe we have some tour guide or some tour booklet that gives us a perspective of what we want to see. But then there are some interesting places that we would like to go. Maybe there's some landmarks, maybe someone from your family has already been to France. I haven't. And there are certain things that are particularly interesting. But there are also some diversions. Someone put it as a serendipitous event where you actually take a scenic tour and you find something that maybe you weren't expecting, but it has some intrinsic value to you. So there's also that as well. So we can think about maps and waypoints and points of interest, but we can also think about user-preferred routes as well in terms of, well, this is a really nice side route that you might want to take to get some value out of it. So we flipped this whole notion of retrieving from the electronic perspective on its head, and we can talk about best practices from even our own vacations. So, you know, if someone has been successful in the vacation, then there's usually some planning here. But from an information retrieval perspective, we find from many of the studies that a lot of the people in this room have done is that they end in frustration often. They sometimes are unsuccessful, and there's often some overlap in the goals between users. Okay, so what we were to actually apply some of the best practices from the travel industry or from our own best vacations to this approach. So we can think about general places to go with our queries, but we can also talk about things that I call roadmaps. Some people call them query trails or threads of the search. But in that, there are potentially some points of interest. Now, the goal here is to give the user the ability to get not only the endpoint or the destination, but also that serendipitous event possibly, because they actually can expand out this roadmap and see what those points of interest are. And before they commit to actually going down the path, have some landmarks, some visual cues that pop up and say, hey, this is what you will see if you take this trip, thereby giving the flexibility of either committing to that or backing up and doing something else. In addition, we have this notion of basic roadmaps and user-applied scenic routes or preferences, which can also take what we already know as well as what we bring to the table. So almost like a bring your own route. And if you think about what the typical GPS devices do today. You can actually say, I want the fastest route, I want the scenic route, I want something in between that. Something like that is what we're also doing with this prototype. So it's a framework, it's the prototype, bringing the wisdom of the masses as well as bring your own roadmap of success to this, which actually will allow for collaboration. The last piece here, real quick, I know I'm running out of time here, is looking at how we can expand this search paradigm to mobile devices. What happens with this prototype is that we encode the road maps into QR codes so that they can actually be pushed over to mobile devices, thereby allowing this split notion of starting a search possibly at the desktop and then going to the mall and continuing based off of what you see there and where you want to go. Okay? And future work is here. Thank you.
Okay. When I met Jing this morning, and she told me that when she was preparing for slides in the flight, someone next to him told her that she's using the same template. Now I know who he is. Is that you? Yeah, this is a very good usability result that this template has been preferred by a lot of HCI researchers. The study is about the effect of cognitive styles on the user preference in an information system. Before I start my presentation, I want to mention that this study, unlike the two posters I did introduce this morning, this study is derived from a UAlbany faculty research grant, which I received right after I started the job. So this data analysis is based on some existing data analysis. The data was collected a couple of years ago. So I want to give my thanks to HCIR and also my university who provided me a lot of support, research support during the past years. And in this study, data analysis, we focus on, this study is based on a larger experiment, in which 16 subjects did several tasks using an information system, which is what I'm going to introduce here, the Web of Science system. And the other 16 different subjects were using a system called an information visualization system called SciSpace. And when each subject comes to the experiment, they first did a cognitive test. Then we give them a tutorial of the system, either could be the Web of Science or could be the SciSpace. Then after the tutorial, they did all those tasks. And before and after each task, we collect some information, collect some questions using questionnaires. And also at the very end, we ask them experience about the whole experiment and all the tasks. So this is a Web of Science system. I'm not sure how many of you have used them. And this is this system. By using this, researchers can access to a lot of leading citation databases. And you can see from the screen that all the scientific literature were represented by a ranked list of results. And here is the cognitive test we chose. Cognitive test is a construct which can be used to describe the habitual model of a person's perceiving, thinking, remembering, and problem-solving process. And we chose Peterson's ECSAW test, in which the style preferences are measured by comparing their mean reaction times on the holistic questions with their mean reaction times on the analytic questions, so that we can collect a WA ratio, which is the holistic analytical reaction time ratio. You can see from the results in the next slides. So these are the tasks we gave to each subject. And the task is categorized into two types, analytical search and spectral. So if you are interested in why we chose these tasks, we can discuss after that. And also, these are some results. We measure their task performance based on time of task completion, satisfaction, result correctness, number of mouse clicks, and spectral recall, which was specifically tailored to the spectral tasks. And also, you can see from the results, we categorize them, the group of subjects based on their median of their WA ratio. We didn't find, across these two groups, we didn't find any significant results in terms of the performance. And in the analysis of the other information visualization system, we do find some interesting results in terms of these measures, in terms of how cognitive styles have a significant impact on the user performance. So if you are interested in the results, one already is in press in Journal of Information Research. The other one is a poster we did to compare the search effectiveness between the system. And also, I want to thank all my collaborators for this project. And this is our contact information. Thank you.
Okay, so we have one more talk, and then we'll do questions after that. Did you put your slide on here? Wait. Where is it?
Hi everyone, I'm Mike Zaro. I'm a PhD student at Drexel University. I'm going to talk about some work I'm doing with my advisor, Xiaolin, who's here, on how we can help the about 140 million health information searchers in this country find high quality, useful health information as the intermediaries, doctors, nurses, hospitals, other sources are kind of somewhat being replaced or at least augmented, a process called apomediation by Eisenbach, with information systems, with search and browse techniques. So, coming from a digital library background, the challenge as I see it is how can we use some sort of metadata or labels or terms to provide what have been called navigational signposts to these users. So if we see that, heart attack, a term I might use as a lay user, well, really myocardial infarction is what a doctor might say. Now, this is a very simple example. I think most of us in this room, at least, would understand this, but perhaps there are even users out there using the web today who wouldn't understand this. So how can we help them, and how can we help ourselves, more educated users with more complex tasks? So to guide our work with this, we looked at how we can use MESH, which is a controlled vocabulary published by the National Library of Medicine, and social tags from delicious.com, which has undergone some changes over the past few months. So that's a little bit of a challenge for us. To really serve as filters while users are searching in an interface we designed. We'll see that in a second. And also, as we designed this interface, we saw that maybe we could provide the expert PubMed resources from the National Library of Medicine, which are medical journal articles, really high-level stuff that most of us probably couldn't understand as a lay user, and also Yahoo results, which would be the more general search engine results. So in the experiment, we pulled in 20 students from Drexel University, 10 lay, we call them lay users, students with no medical training at all, and 10 health and medical students with at least 2 terms of training. So in one of the scenarios, we asked them to apply 2 filters before answering a question. In the other 2 scenarios, we just asked them to answer a question with no additional instructions. So here's our prototype, fairly simple. A query is sent to 2 APIs, PubMed and the Yahoo. Return with these results and mesh for the PubMed. It's sent to an interface intentionally designed to be simple so the user can understand it, and our users commented that the simplicity was actually a benefit. On the left, you'll see combined the metadata we retrieved. So we have mesh and we have the delicious tags here. We didn't tell them which was which. We wanted to see which they selected on their own. And they're ordered by frequency. On the right, we have the Yahoo results combined with PubMed. You can see it's fairly obvious which are which to us. But users some of them liked it, some of them didn't, and they would explore into even PubMed results, as we'll see in a second. So, of course, I'm in the lab with them, and the system is great, it's helpful, it's satisfying. Everybody loves it, which made me feel great. But how useful is that? I'm not sure. Some of the comments were actually, I think, really useful that we see, users could look at the filters, as we call them, find terms, and actually I saw one user highlighting with her mouse the terms and then looking in the search results to try and find that term somewhere in there. So they kind of had a feeling this is a health search interface. This is something that I can really find new and interesting. Let's call them signposts here. So as our users looked at Yahoo and PubMed results, we see that they viewed a lot of Yahoo results, viewed a lot of PubMed results, but really the answers came from the general search engine. Why is that? Well, even for they're not necessarily experts, but the more trained, when you go to PubMed, it's not the most user-friendly system, at least for the tasks we were having them do. So here are the terms they clicked. You can see lay users and we call them medically trained, fairly similar. This is for finding the risks and benefits of gastric bypass surgery, treatment outcome risk factors. Fairly useful. But how many of these are delicious tags and how many of these are mesh? Well, it turns out there were no delicious tags selected, at least for this one task. Well, why is that? You would think that these lay users would find the terms, from the wisdom of the crowds, and off we go with these great signposts. Reality is, health, research, tags like that are the most common. They're not really useful for this. So we think maybe using mesh-controlled vocabulary, assigning them to general health resources could be useful. And at the very least, thanks to our keynote, at least this student learned a lot to guide future research. So if nothing else, thank you.
Without further ado, I'm going to introduce the team from L3S. And buddy, it's all yours.
Hi, thanks. So I start with the first task, which it's about MapReduce. And the idea is that, so I'll just, I don't know if you can read it, so I'll just point out a little bit what it's about. So there was a blog post where David DeWitt said that MapReduce is not novel and techniques were employed more than 20 years ago, and the idea is to find publications that support this, or say that nothing, so that this is not true by not finding them. So what I'll present is our system, which is called Free Search in spite of the logo there. So we're changing that. So it's based on an older faceted DBLP system that we had. And the idea is that, so starting with MapReduce, since we know that it's about parallel data processing, we can input that query. And I can point out at this stage that actually the HCIR challenge helped us and helps us also with future ideas because, for example, there is this thing with going from MapReduce to parallel data processing, which now we know it, but it's actually more a matter of putting in MapReduce, and the system should use something like I don't know, be the ontologies or some synonym lists or yeah, thesauri to come up with this thing. Right. So we input this query. I'm also going to walk you a little bit around the system. So on the left side here we have the facets, like you know them from all other systems. The system is based on Solr, so this was easy to do. What we have in this part here, it's a thing which we are now working on, so which has suggestions for the query terms in which fields basically, so what type you might want to search. And it's also based on the facets. So for other queries, it might be a little bit more meaningful. I just show you around. Right. So, and then going to the results, we have a ranked list like you are familiar with. What we've done, we also made the fields maybe a little bit more simpler by putting authors, editors, contributors together in a by field, so which is a little bit more natural language. We have also in, which is something like it can be publisher, source, it can be even the year and conference and so on. And when opening actually a result, then it would go into the separate fields and tell you exactly what you are looking for. But for the overview, it was easier to keep it simple. Right. And the interesting fact for this task is actually we know that the blog was from DeWitt, and we have also results pretty much on top. And if we click on the author's name, then another search will be triggered with by and the author. And we've also been told that the query or that the publication should be more than 20 years old, so we can also do this. This is then another idea which we will be working on, not to say year less than something, but saying something like 20 years old, or actually before 1990, maybe. So to go more into this natural language kind of queries. Right. So coming back to the task, we can actually find here this publication, which, well, if we read the blog post, and we also see that the results are also in there, so we can check this and see that this result on third place is actually the one that we are looking for. Right, then going to another search task. We took these people who like this person also like, which is about collaborative filtering. And the question is, has anyone applied collaborative filtering to people search? And what we're gonna do here is create a query which, so we have different, we support Lucene query syntax, which normally comes with Solr. So we can have a phrase query, which we do collaborative filtering, right, as a phrase. And then we have, we can have Boolean queries where we have, it's people search, but people can also be person. So we can do something person or people. So this works, and then search. Right, and what I want to show here is actually also this topical clustering, which works on the results that are being shown. So I'm gonna go to 100 results. That means online this clustering is being performed, and it uses the Kara2 clustering engine with a Lingo algorithm, and you get these topics, which are based actually on the titles of the results. And if you look at them, one of them is social networks. And we can go to this because it goes into this direction of people search and narrows down the results. What happens when I click on it is that it's actually added to the query. So if I look at the query, it's still the same one, but at the end, social networks is being added. And the terms which are here are added with and, so all of them have to appear. Right. And then, right, some other functions would be like if we don't have an advanced search box, so we want to keep it as simple as possible, and for the beginning we have this query syntax button, which then opens a short explanation how you can search and what exactly are some fields which you can use, and how some example queries and some operators that can be used. The idea would be then in the future to support this kind of, let's say, natural language queries. So having some words which we can detect that the user has an intent of searching with some different operators and transforming the query in accordance. Right, so that it's, we want to keep it as simple as possible and have just this one search box, and don't get it too complicated for the user. Right, and again, looking at the results, we will find, so we find this publication referral web, we have semantic collaborative filtering with Wolfram, we have the link prediction problem for social networks. So there we go, and we find these kind of publications about collaborative filtering for search. Right, so that was it from my part. If you have any more suggestions, ideas, anything, I would be glad to hear about them. So we can have them then sometime to talk about that.
Yes.
I don't know if it's now with questions.
Ask questions.
Okay, great.
Yeah,
so please. Right. Yeah. Yep.
Are they
it doesn't know concepts beforehand. It just creates them from the titles of the results. So in this case, we have 100 results which are returned, and in the titles of those results, social networks appears pretty frequent. and that's why it's put as so documents are being clustered, and from that cluster, social networks appears in the titles of those documents, and then it's made as label of that cluster. Yeah. Yeah.
Always can.
Yep.
If under topics I wanted both mining or browsing, I can both go in and edit the and add an or.
Yeah, you can do that. What happens now is actually if I click on mining, then it will, I don't know if browsing will appear again because the clusters are generated again from the results. So you say, yeah, but it's, I mean, the idea would be,
done that by hand up in the...
Yeah, yeah. So you can do like mining or browsing. You get the idea. Yes. You see, that's always the problem. I mean, you are. That's the thing. You can never be sure actually that you didn't find what you were looking for. Maybe that's all. If the system is good enough, it will help you maybe to find, let's say, 99% of the cases whatever you are looking for. But there is still this uncertainty that you. So, well, in order to improve recall, it would be, so one of the things that we would do now to improve the system actually is try to use thesauri. The problem there is they have to be actually domain specific to help more. And if they are not, they might be too general. But let's see about that. We actually have also now some query translation, so it can search, you input the query in English or in some other language, and then it translates it into different other languages that you specify. So because we have documents from, well, not in sites here now in this data, but in other data that we have it also in different languages. So that is also a problem. Yeah.
Question, I guess, for everyone. Part of your success is due to the fact that you're able, as a human, to actually start with a query, in the first case, not to be mapped. How are we supposed to take that into consideration as?
I'll answer that because I guess it's to me, which is that obviously a system that requires that is more flexible with respect to that is better than one where, I mean, take the extreme case. We tried to have queries where it wouldn't be, oh, I just know the answer for everyone, or that wouldn't be interesting. The instructions to participants, they were allowed to use their own domain knowledge, and if I recall a paper that Martinini wrote a while back, part of the point of these systems is to adapt to that. So if it is your feeling that the system only works for somebody with a very high level of domain knowledge, that's a negative. If it's your feeling that the system is no better for somebody with more domain knowledge, that would also be a negative. So it should be the degree to which it adapts. It is up to the presenters to convince you of the flexibility of that in their limited time.
So that's why I was saying these tasks actually help us also for the future to know how to make them to improve the system. So thank you.
Thank you.
Should I leave the laptop? Want to use it, or
everyone's going to have their own laptop?
Okay, good.
Not everybody is doing. Some people are using local systems. Thank you.
Yeah. Well, I want to keep it plugged in.
Sorry.
So go ahead and unplug.
We can always borrow since Gene actually had a minute or two in his previous presentation to introduce the system. Yeah. All right.
Is there a power supply over here or a power outlet over here?
Yep.
Okay, go ahead and unplug it, Kathy.
Yeah, while you wait, if you have laptops or netbooks or iPads, I do encourage you to look at the description of the challenge if you feel that will inform your vote. Now, it's one thing I want to say with regard to the previous and all the challenge participants. Obviously, I mean, I could have given a task on there that would have been completely impossible and just seeing how many days or weeks they spent. Of course, it's very difficult to.
That's all we had.
That's true, actually. But it's very difficult to demonstrate the failure to find something. So you do have to use a little bit of imagination, I think, in watching this, as to seeing what the experience would be like, what's the support you get. And the questions are sufficiently subject to interpretation that that's actually something to take into account as well. Without further ado, Gene, all yours.
All right, thanks. So I'm going to do the MapReduce task first, and I just started it and typed in the query Bubba, Grace, Gamma, and MapReduce in quotes. Those terms, Bubba, Grace, and Gamma, come directly from the blog post that motivates the task. Okay, and so I did that. I apologize for the layout here. This screen really wants to have more pixels than this projector is giving it. But I'll do a little bit here. I'll just size this and move this over a little bit to give it a little bit more space. Okay. So this is Lucene running under this interface. So there's nothing magical about the search. It's just plain vanilla Lucene. And this search, so this is the system I talked about earlier. And you can see we have an article here on this algorithm, and the URL of the PDF doesn't exist. This is a common problem with this collection because it's kind of stale. But I can display the text that was indexed because we did get the text, and that's cached. And so we can look at this article. And it does, in fact, talk about the Grace hash join, which is a parallel database technique. So I'm going to mark this thing as useful. I'm going to slide this back so that you can see more of the results. This thing doesn't appear to be the case. We can look at it. Again, it may or may not. Oh, it was downloaded as a compressed PostScript file. Not very useful. So again, we can just look at the text, and there it is. I could also open it up in a separate window, but I won't bother you with that because. So I decided this is not, in fact, what I want to see, so I can just hide it. And then I can look. And that means that document won't be shown by default in subsequent queries, but it's still available. So here's a paper that compares 4 different parallel join algorithms, just kind of related to what we're talking about. So I'm going to say, yeah, that's good too. And here we have another document that's abstract logic flow execution model for parallel databases. We can look at that, not found, hello, etc. That's also useful. Now what I'm going to do is a query expansion step. I've taken these 3 documents that I decided are useful, and I'm going to find other documents that are materially similar to those 3. And the system runs, and you can see that here it's building up a query history. So using the terms that I had typed plus the documents that I had selected, it now finds some results. And it's showing me as it runs. So it's found these documents that I've already seen before. I can tell that because one thing I've already marked them as relevant. And then I can see the document number 3 is a new one. I haven't seen that before. I mean, it was retrieved before. This is where the histogram comes in. But it was retrieved at a low rank. In fact, it was retrieved at rank number 13. That was below the fold. I never saw it. But now it's promoted to a higher rank. And so, again, it's an interesting thing. I can save it. And now I'm just, so these documents are in fact sort of about what was being talked about. Although, again, maybe it's too easy and just taking words directly from the blog post. But what I'm going to do, just for sanity's check, is I'm going to run another query. Yeah, and that's going to produce 0 results. So that's fine. Or it's going to produce results for parallel, and that's, you know, life. I don't have spelling correction here. Sorry. I'm going to rerun that query. And so now you can see that it's producing completely new documents, at least in the top bit. And in fact, I can tell right now that looking at this, that I haven't seen any of these documents before. They might have been retrieved. I need to add that as a separate facet, but at least I have not looked at any of them. What I can now do is take the results of all of these queries and combine them and do that rank fusion operation I talked about earlier. And so now you can see that these documents that scored high on the queries get high ranks here. And as I go down the list here, number 5, for example, is a paper by DeWitt and Gray. We know from the previous presentation that DeWitt was the author of that thing. So here again, it's not found. Again, we can look at the PDF. I'm sorry, the text. What was there was a fancy 404 page, right? And so I can say, well, actually, it was a PostScript file. Okay. Anyway, so I've saved these things. I can now look at my summary, and this is what I've done in this session, right? Starting with the query here. It went up and saved some documents, hit some documents, and this gives me a sense of what's happened in the session. I'm now going to go and switch to the second task, which is the facet query. And again, I started it with a query which was the title of the paper by Belkin et al. And that paper itself actually appears in the search results here, number 4. I don't know why it's number 4, not number 1. Not going to worry about it, but so I'm going to mark it as useful. I can also just select it directly and say, okay, find me other things that are like this, because I want to kind of get a sense for this space. And it's going to run a query, and now you see tweets mentioning what I'm doing up here. It is not yet integrated into the tool. So I'm going to look through. So I selected this document, and it's found some other things. What I'm going to do is I'm going to look through this, but I'm not going to see in here anything that catches my eye as something that is, in fact, relevant to what I'm doing. So I'm going to try a different query. So I'm going to clear this. That's the query history that I have to date here. Shows that I saved one relevant document. I'm not going to worry about it for this purpose. I'm going to type a query named faceted search history, because I think that's kind of what I'm after. So now I've run the second query. I get back a bunch of documents. You can see that they're all new. I can kind of scroll through this. And there's a flamenco paper, which we can look at. Is it going to be alive? Yes. There's the PDF. I can actually scroll through this and read it if I want. I'm going to say, yeah, this is good. It gives me some idea of things. I'm actually going to look at this one here, which is a paper by some people in this room, at least one of them, I think. No, he's not here. Oh, no, he's up in the corner. And this paper, I'm going to size this out larger so you guys can see the text better. Hello. Oh, the screen doesn't let me get any larger than this. Okay, I am going to open this in a new window so that we can see it. So this paper talks about personalized interactive faceted search, and I can look at it. Let's see, what was I supposed to do next? get some idea of the terms. And what I'm going to do is go back to this and change my query to faceted metadata, because that's what it was talking about. Information, cannot type. Retrieval, not type. Interface. So just some terms that were mentioned in here that I think are reasonable to add to the query. I can now look through these results. I'm going to size this back down. You can see more of the search results. And let's see. Look at this thing. And this document, and this is where Marcia Bates will be proud of me. This document in reference 6, so it talks about, I guess, I'm sorry, I need to open it again in a separate tab so you can read it. But the first sentence here says, a faceted taxonomy is a set of taxonomies, each one describing the domain of interest from a different, preferably orthogonal point of view. Reference 6. Any guesses as to what reference 6 is? Those of you in library science? That's right. All right, and that is the next query I'm going to run. And when I do that, oops, and what I'm going to do actually is go to the references and copy it out so I don't make any typing errors. And here's the reference 6. It's Ranganathan, the colon classification. Copy that. Put it in here. Going to get rid of the just because, you know, who knows. In fact, I'm going to get rid of the quotes because being generous about it. And this first result, as it turns out, mentions his contributions to facets and classification on the second page over here. And I believe that that is sort of inspiration, if you will, for those in library science. So that gives you a quick sense of what the system can do. How much time do I have? Okay, so that gives you a quick sense of what the system can do.
I want you to be able to take questions.
Yes, sir.
I hate to ask this question, but why not just get a paper in geography, right? Reference list.
Yeah.
Oh, did it in fact cite it?
Yeah.
Well, I don't know, but this whole notion of doing sort of a citation genie.
Yeah, right. So absolutely, and one of the things that limited my ability to search here was implementation time. But the citation metadata was available and should be available, and I think that you might see other systems that actually take advantage of it. I chose not to use that, but yes, particularly for corporate where that metadata is available, you should just be able to pivot on that, search, do metadata searches, and presumably find the answers more quickly. This just shows that you can use different techniques to get, in effect, to the same result. And now I recognized that name having done the search. I didn't, I mean, I should probably have read the paper more thoroughly, but I figured that would probably take longer than trying to poke around and trying to do time to understand it. Anyway, thank you. That's right. Well, not for this task. No, it's all about search. Yeah. The answer is no, but it can. Because, as I said, when I built the system, I concentrated on the user interface and on this exploratory stuff. The back end is just vanilla Lucene. Now, Lucene supports, you can do spelling correction out of Lucene, and it's just a small matter of programming to get that out. I chose not to spend my time doing that for this first pass of the system. It's certainly something that should be done. So spelling corrections, the ability to handle synonyms, all of that stuff can be put in the index and will improve the system. Just there was limited resources with what I could do. Yeah. Yes, right. That's right. So, yeah, so I could compensate for that way by running multiple variants and doing fusion of results, as Mark suggests. I mean, that's a perfectly reasonable strategy. It's probably better not to force the person to do that and to have the system do it automatically, but I could certainly compensate for that this way. Yes. Are we in time? Any more questions? Yes. Yes, this is completely stateful. You can log off, come back 10 years later, and if the server's up, it'll be up.
Okay.
Thank you.
Let's give Gina a hand.
Hi, everyone. It's a pleasure to be here. I'm very impressed with the quality of the talent here. And where were you guys 18 months ago? That's what I want to know. In fact, I would. We couldn't even spell HCIR a year ago. Let's see if this is magic. Okay, I'm Ed Heinbuckle, Visual Purple. All the difficult questions I would ask that you direct to this gentleman over here, Brian Olson, our CTO. He's the technical brains. The fellow that is responsible for all the magic sauce and what you're going to see today is a fellow named David Osby, and he's not here. He's our chief scientist, and we keep him in a locked room in an undisclosed location. David and I have been working for about 20 years together. I want to frame what you're going to see today, where it came from and why we're up here, because we have a bit of a jaded past. We have been in the entertainment software world for about 15 years, and in the last 12, 13 years, we've been in the simulation world doing training, mostly for the government. And through those efforts, we got the opportunity to work with a lot of really interesting folks with some really interesting problems. We've done a lot of training for analysts. So the tool that you're going to see today is a tool that really came from demand of the user. And the whole process has been driven by the user. We haven't had the luxury to do much studying. We take a, what's the term? There are many terms out there, but we do an incremental development approach to life. So we do rapid prototyping. We try it, it works great. We head off in that direction. If it isn't, we stop there. In that cul-de-sac, we turn around and we head where we need to go. Yeah, I know that's the buzzword. Yeah, exactly. Yeah, I know it's had many different monikers over the years. I call it the pragmatic approach. And since we're not a venture-backed company and we have clients, we have to be very mindful of that. In fact, what you're going to see today is we didn't do anything really cool or special with respect to the presentation of the XML data. So I'll apologize for that up front. But it's the core system. We basically configured Gister to look at a database instead of looking at the web, because Gister lives out there today in the hands of analysts for what they call OSINT, for open source intelligence. This little globe you see up here, and we call these the thumb walls. And you can go to the website and play the video and all that, but I don't want to waste a minute on that. It's a minute and 20 seconds. I don't have time to waste. But the point is, we stripped out the thumbs because we're just playing with this database, okay, this discrete database. And we did that in conjunction with some other work where we're piloting the system in classified environments. So the timing on this was really apropos. And also say up front that there's no worry about there being any domain expertise involved in this, okay? Because I'm the guy that did the searches, and I haven't a clue what the heck you guys are talking about, okay? Even though you see, I mean, I can't even spell ontology today. Even though you see this globe, or this, we call it a globe, you guys call it a sphere. In fact, we agonized over, what do we call it, a sphere or a globe? We agonized over, what is this? Is this search, is this Google on steroids? I mean, people would ask me, what are you guys doing? And I would try to explain it, and I always sort of devolved to, yeah, it's Google on steroids. And in reality, it's exploratory search, I guess is the right term. We use concept search to begin with. But the reality is we're working with analysts, and oftentimes these folks are presented extremely difficult problems to solve in very short periods of time. So we thought, well, visual purple, here go the purple shirt, but visual, we should somehow be able to let people lens into the data in a way that they can quickly grok through it and be able to do something what they call actionable intelligence with it. Okay, so that was our mission on this. And I won't go into the core technology came about for some unusual reasons some time ago. And the reason GISTR can even exist today is something we call looking glass, and that is an LSA-like approach to the data. So we have a high-speed, an automated high-speed functionality or capability with looking glass, and that's what GISTR loves, unstructured data, and it just chews it up. So unlike LSA, we don't have to worry about the computational overhead, and we don't have to worry about having a large corpus to play with. So low data environments, it loves that, and it lives for unstructured data. So what better way than to turn it out and outward to the web, and then of course to the HCIR database. So let's. I couldn't resist. I did two. Let's talk about the indexing. We are not indexing experts by any stretch of the imagination. The indexing became a side project that went down about 3 levels of priority until I finally beat up on some people because the competition was coming up. And the problem with that is we just basically started cranking on a day and a half or 2 days total between server crashes, etc. And so we didn't do anything fancy with the data. We didn't clean it. We just got it there, and we figured we'll see if GISTR can deal with this in a meaningful way. And you'll have to be the judge of that. So nothing fancy on that. Let's see. Is there anything else I'm missing? Well, we'll just kind of get into it here. Let's go look at the first question. I did 2 questions, and I had 1 hour to do this. Once we got, in fact, I did these searches when the database was still being indexed. So the first one I was a little intrigued by, well, graph drawing on a sphere. Okay, so, just the biggest challenge for an analyst, especially when they're in an unfamiliar domain, which I was, is asking the right question. And the question's always changing, right? That's one of the big problems out there. So we wanted to come up with a way of working through the data. So I went and I basically did graph layout algorithms, drawing graphs, surface, sphere. We don't support Boolean operators. We have this concept we call loose quoting. What does that mean? That means that we're looking at all the relationships of all the terms across the corpus, okay, in real time or near real time. So let's see here. So we're logged on here, and I've got a save search, but I'm going to actually do the search.